today the next new chapter is matter around the sphere. Okay, so these are the checklist of the chapters. First, we will learn about.
And pure substance, ma'am. Also, there are three types, ma'am. Metal, non-metal, and what more is there?
Metalloids. Huh?
Metalloids, yeah.
Yes. So these are the topics: pure substance, mixture, solution, suspension, colloidal, separating the
And
component.
compounds are not there.
Compounds? Yeah, compounds are there, mixture and compounds. In pure, you will get two things, the element and the compound, and the physical and the chemical change. So let's start with the...
Sorry, ma'am, I'm late.
Oh, hello, Arham. Yes. So let's start. Arham, today new unit is matter around a sphere. Okay? Yes? So what is matter around a sphere? So what is matter?
Matter is something that occupies space and has
Matter
mass.
is something that has mass and occupies some space because like gas and like all three states of matter.
Yes. So this is also a matter. This.
Yes.
Because this thing is occupying space and some mass in it. Yes, Shazam?
Ma'am, is light, sunlight matter or?
It's sunlight matter. Okay. Arham, is sunlight matter?
No, it doesn't have any mass.
Oh, yeah. And Advika, is sunlight matter? Advika, are you there?
Hello, ma'am, can you hear me?
Yes. Is sunlight matter?
Ma'am, I didn't understand what you mean.
Like this is Shazam.
Ma'am, light is not matter because it doesn't have mass and
Oh,
it
your
does not occupy
question.
space.
That's what Arham.
Mama, I kept hearing you say, "Do you like matter?" I was like, I don't understand your question.
Okay. No, that sunlight is matter or not. So no, it's not a matter. Okay, so this is also a matter because it's having some mass and it occupies some space. Now, what matter is classified into two things. Here is also like pure substance and mixture. It means...
Ma'am, mixture is also known as impure substance.
Yes, impure substance. Pure and impure. Okay, and what is pure? What is pure?
Ma'am, only like one element or...
Yes, it consists of only one type of
element.
Consists only one particle, one type of particle, we can say. Consists only one type of particles. And what is impure? Which
consists of more than one type of element.
Two or
compound. Compounds. We can classify them as compounds.
Yes, impure. No, impure we have two parts. One is element and another one is compounds. In impure we have two. One is heterogeneous and another one is homogeneous. Two or more types of particles. Okay, now what's the next point? Can you give me any example of pure? Any pure example?
Iron.
Iron?
And sodium. NaCl.
Yes. Copper.
Ma'am,
is
hydrogen, oxygen.
Oxygen, hydrogen, neon, pure water.
Fluorine.
Dioxide. Yes, all are pure. And I'm getting it right? This is pure. Why? Why copper is pure? Because in copper atom inside...
I'm not getting it.
You are not getting it? See, what is pure? Pure consists of only one type of particle. Like, example, if you are saying...
Ma'am, don't tell particle, ma'am. It is more actually confusing. Tell element, ma'am. Element is...
One type of elements. Okay, one type of element. And why we are saying copper is pure? Because in copper, atoms also inside the copper is only made up of copper. Only the copper thing is there. Like in oxygen, only the O2. In carbon dioxide, only the CO2, the mixture of CO2. In the air, only the oxygen is present. And in the carbon dioxide, it consists of CO2. So only the CO2 will be there.
Ma'am, water is not like... Ma'am, is water pure, ma'am?
Yes, pure water, yes.
Ma'am, but it's H2O. Hydrogen...
H2O, because in water, it consists of only H2O everywhere, right? Only the pure H2O will be there. Okay. That's why water is pure. Arham, got it? Arham? Yes, okay. And what is impure? Any example of impure?
Sodium chloride.
Very simple example, we can say tea. Coffee.
Yes. I was going to very complex example.
Yes. Tea and coffee is a mixture of milk, sugar, and that adrak, है ना? And coffee is also a mixture of lot of things. So that's impure, correct? And impure is also known as mixture, है ना? Arham got it? Why tea is impure? Arham?
And because it has like a lot of ingredients, things in it.
Yes. Combination of lot of things. That's why we see here is what 2 or more types of elements. So in tea, here we can say particles because in tea the milk, the sugar, all are the particles. Okay, so that's why tea is impure here, and here the pure water, the oxygen, and the copper is pure. Okay, any doubt? Anybody till here? No doubt. Anyone? Okay, so this is what? This is a salt water. Salt. Okay. I'll ask later this question. Now, in pure, Advika getting it? In pure also we have
Yes, ma'am. Ma'am, I'm getting it.
In pure also we have 2 things. One is, see, this is pure. In pure also we have some subtitles where one is element, another one is compounds. Okay, and what is element? Element is a simplest form of matter which cannot be further subdivided or simplified, divided. Okay, element.
And compound is made up of more than one element.
And what is the example of compound?
And sodium chloride, NaCl plus H2O, you can do that.
Carbon dioxide, water. So what is element? Simplest form of matter which cannot be further divided or further simplified, we can say.
Ma'am, H2O2, ma'am.
H2?
H2O2 is also compound, ma'am.
And element, we can say oxygen is an element.
Simply, salt is also a compound, ma'am.
Salt is a compound. And what is compound? A compound is a substance that results.
And how is salt compound?
It's sodium plus chlorine.
It's compound. It consists of 2 or more different chemical elements.
Na plus Cl.
Ma'am, but then is water compound?
Is water compound? Shazan?
Yeah.
No, ma'am. Yes, ma'am. It's compound, ma'am. H2O. Ma'am, 1 atom of hydrogen and 2 atoms of oxygen.
Yes.
Then got it.
Combination of 2 or more different chemical elements is compound. Chemical elements. Okay. Till here you got? Now, element is also subdivided into 3 parts. Elements are also divided into 3 parts. What are they?
Metal, non-metal, metalloids.
Metals, non-metals, and metalloid. What is non-metals? Sorry, what is metalloids? What is metalloid? No idea?
Metalloids, ma'am. I have idea, ma'am. Can I refer to my class notebook?
Okay, refer it. Arham, what is metalloid? Metalloid is a mixture of both metals and non-metals.
Yes, ma'am.
Got it.
Ma'am, like boron, silicon is there, and ma'am.
Example, boron.
Ma'am, germanium, ma'am, is there.
And what is simple metal?
Ma'am, iron.
And non-metal?
Salt.
Yes, salt. Okay. So elements are subdivided into 3 parts: metal, non-metals, and metalloids. And here the impure is also known as the mixture. So mixture is divided into 2 parts. Can anybody tell me? Mixture is subdivided into 2 parts. One is homogeneous.
And ma'am, one thing more, ma'am. There are 93 metals and 18 non-metal and 77 metalloids are present.
That we will cover. Okay, tell me 93 non-metals, 93 metals or non-metals?
93 metals.
And non-metals?
18.
Yes. And metalloids?
Only 8.
Only?
8.
Yes.
7. I'm so sorry.
And that's what I was thinking. Okay, 7. Cool. Now, here the mixture is subdivided into 2 parts. One is homo and another one is hetero. What is homogeneous? Anybody, any idea what is homogeneous? Arham, Advika, and Shazan? No, homogeneous is same phase. We can say homogeneous is Shazan. Yes, Shazan. And
a homogeneous mixture, ma'am, is a mixture that ma'am, it's a gaseous state. Ma'am, it is in a gaseous state.
It's in a gas state.
And ma'am, yes ma'am, it's in a gaseous, and ma'am, the mixture is at the same temperature.
Yes, Advika. See, homogeneous is, in simple words, we can say that homo means same.
Ma'am,
Okay.
both the elements are present in same amount, same ratio. Ratio same.
Okay.
Means there are two elements, ma'am, and the ratio of the elements are same. Means
Yes. Yes. See, like salt solution. If we can if we'll take the example of a salt solution. So if we mix salt in water, only one phase it will become. Salt will fully dissolve in water. So that's we can say like salt plus water is an example of homogeneous. Salt plus water, because if we will add a salt in a water, it will be full same phase, means full one phase. It won't be like that salt is this much, water is this much. No, salt will fully dissolve in water, right?
yes, ma'am, because there are intermolecules present in water.
And in heterogeneous, we can say the example of sand plus water, because if we will add sand in water, sand will not fully dissolve in water. Like this much will be sand and this whole will be our water. So that's a different phase. This sand is in different phase and this water is in different phase. That's why we call hetero is a different phase, and this homo is the same, because if we will add salt in water, it will become a full same phase like this. See, this is salt water is homo or hetero, Arham? Is salt? I don't know. You think and tell. Homogeneous or heterogeneous?
But ma'am, if you dissolve excess amount of water, then ma'am, means the excess amount of salt, then it will not dissolve in water.
Very excess amount of salt if we will.
And it will become heterogeneous.
Then it will become like small amount. See, like this much only.
Ratio should be same. Water and.
If this much, Arham, tell if salt is dissolving in water, it will be homo or hetero? Okay. And Advika, it will be homo or hetero? Advika, you are there or not?
Hello?
It will be homogeneous or heterogeneous if we will dissolve the salt in water?
Ma'am, will be homogeneous.
Why homo?
Ma'am, because the particles find space between the between the particles of the water and settle evenly, and even if you try measuring it, like the amount of salt will be equal to the amount of water.
And it will be in one phase only. That's why
Yes,
we
ma'am.
call salt water is a homo. Arham got it? Because homo, see Arham, homo is a same phase, right? If we are adding salt in water, it will become a full same phase. But if we will dissolve with sand in water, it will be sand will not fully dissolve in water. Sand will be here in a different phase. Water will be in a different phase. That's why salt plus water, sorry, sand plus water is a hetero, because it will not dissolve fully. It will not be in a one full phase, and this sand water will dissolve fully in the water. Okay, Arham. So this is a homogeneous. Arham, got it? Arham, are you busy in something?
Yes, ma'am.
No, you are busy in something. No? Okay. Chalo. And yes, one question for all of you. And what is oil in water? Oil in water is homo or hetero?
Heterogeneous, ma'am. Oil does not mix with water because ma'am, density of oil is less than water.
Because both are having
hetero.
It will be hetero now,
Mixing it
because of the different in polarity. Oil and water. See, okay, let me show you one image, then you will relate. Where's that? See, this one. Oil in water. This is my oil and this is water. Not dissolved fully. It's not in the same phase. So that's why oil in water is a heterogeneous. Okay?
Even if you flip the glass, ma'am, the oil will automatically float.
Oil will automatically float. Yes. So fully like oil and water is a homo? It's homo, right, Arham?
Yes, ma'am.
It's homo.
Was it? What was the other one? Hetero. Was
Yes.
it hetero?
Hetero. Yes, good. Hetero. Now, till this much, what we have seen, like matter is divided into two parts, pure and impure, and pure is divided into two parts. Again, one is element, another one is compound. And now the elements are divided into three subparts: metals, non-metals, and metalloids. And here the impure, we call it as mixture also. So mixture is divided into two parts, homogeneous and heterogeneous. Now next, in pure substance, the two subparts are this elements and the compounds. So we will discuss this. In pure, we have two things. One is, we can say mixture and compounds. Mixture and compounds. Okay. So mixture. What is mixture? Elements. Elements.
More than one element.
Elements or compounds just mix together to form a mixture. And what is compound? See, if element reacts to form a new compound, if we will react this H2 plus
O.
what? O. It will be
H2 plus O2. H2 plus O2.
H2 plus O2. Here, if we will balance, it will be 2, and here H is 4, so it will be
Hydrogen peroxide.
So here compound is what? Elements react to form a new compound. Here we are adding this hydrogen and water to forming a new compound, which is a water. Yes. When they chemically combine, they form a compound. These are chemically combining with each other. The hydrogen and the oxygen are chemically combining with each other to form a compound, which is a H2O, water. And what is mixture? Elements or compounds just mix together to form a mixture. It's very simple. Elements or compounds, just if we will mix this together, just mix together to form a mixture. And the composition of each new substance is always fixed here. The composition
is in a fixed ratio.
Yes.
The composition is in a fixed ratio.
The composition of each new substance is always fixed. It will be in a same ratio, in a fixed ratio, is always fixed. Like example, if we will take example of a water, then here in H2O, it's always 2H and 1O. So this is fixed. The composition of each new substance
2:1.
The hydrogen one and the oxygen one, the composition of each two hydrogen and oxygen is fixed. Like in carbon dioxide, CO2, C is 1, 2 is
1 is 2.
C is
That's
1,
fine.
this thing is 2. So this is what? This is fixed. That's why we say the composition of each
Ma'am, oxygen is O2.
That's
So ma'am, H2O, it is, so ma'am, 2 hydrogen, 1 oxygen.
what? 2 hydrogen and 1 oxygen.
But ma'am, oxygen is O2.
That's O2, but I'm just taking the thing specifically, like in H2O, it will be 2 hydrogen. Okay, just for explaining that the composition of each new substance is fixed, where hydrogen is fixed and oxygen is fixed. Now, here, a mixture has a variable composition, like no fixed proportion. A mixture has a variable composition. Means this is not a fixed proportion. Okay, Arham, here in the mixture, in the compound one also we can say the new substance has totally a different property. Like hydrogen is having a different property, oxygen is having a different property, but if we will add these two, we'll get a water. Water will have a very different property from these two, hydrogen and oxygen. Okay, I will take one example also. See, let me write first. The new substance has totally a different property. For example, let me take example of NaCl, sodium chloride. Here, chlorine is highly poisonous. Chlorine is what? Highly poisonous. Okay, but if we will add sodium with chlorine, it will become a salt, and salt is very useful for us. So that's why here we are saying that a new substance means the NaCl will become a full new substance. It will have a different property than the sodium one and the chlorine one. If we will combine both the sodium and the chlorine, it will become a NaCl, and salt will have a very different property, because here the chlorine is very highly poisonous. And if we will, Shazan, ma'am, I need to go somewhere, so I will leave the class at 6:30. Okay, but where you have to? Arham and Advika, you got this part. The new substance has totally a different property.
Yes, ma'am.
How, Arham?
Yes.
Arham, how?
Because chlorine, it's very poisonous, and sodium, it reacts with water. But when you combine them, it's not poisonous at all, and it doesn't react with water.
And it will become, because NaCl is a salt which is useful for us. Just like here, H2 plus O will get a water. Hydrogen is having a different property. Oxygen is having a different property. But if we will add these two, will get a water. So on adding, will get a totally different property. Now, a mixture shows the property of the constituent substance. We can say the constituent can be separated fairly easily by some physical methods. First, let me write here. The constituents can be separated only by the chemical or electrochemical reaction. Here, if we want to separate the hydrogen and oxygen, how we will separate? We will separate only by some chemical or electrochemical reactions. The constituents can be separated like the hydrogen or oxygen can only be separated by the chemical or electrochemical reactions. By the chemical or electrochemical reactions. Shazan, getting it? Shazan?
Wait, what?
Wait, what? Means you are not. See, here the constituents can be separated by the chemical or electrochemical reactions. Means if we want to separate this hydrogen and oxygen part, then what we have to do? We have to apply some chemical or some electrochemical reactions. Then only these two parts.
Electrolysis.
Yes, electrolysis. So this part you got now, that if we have to separate, only we can separate by these two chemical and some electrochemical reactions. Okay.
Ma'am, there. Yes, ma'am.
Then?
Nothing, ma'am. I need to go.
You need to go? It's only okay. Bye.
Bye.
Bye. Here in the impure, where is the impure substance? This is impure. And in impure, we have two things, the homo and the hetero one. Okay, first let us go through this notes. In pure, we have three things. In pure, pure is subdivided into two parts, the elements and the compounds, and the elements are subdivided into three parts, the metals, non-metals, and the metalloids. So what is metal? A metal is an element that is malleable, means that can be hammered into a thin sheets, ductile, can be drawn into wires, and the sonorous means make a ringing sound when we hit, and conduct heat and electricity. Hai na? Yes, Arham?
Sir, ma'am. Yes, ma'am.
Okay. And metal is what? Metal is shiny. Metal shines. Example: gold, silver, copper, iron, sodium, potassium. All are metals. And what is non-metal? A non-metal is an element that is neither malleable nor ductile. Malleable means it cannot be hampered into a thin sheet. And what is ductile? Means it cannot be drawn into wires. Cannot be drawn into wires. Cannot be drawn into wires. And does not conduct.
Cannot be drawn into what?
Wires. Ductile means can be drawn into wires. No? So non-metals is neither malleable nor ductile. And non-metals do not conduct heat or electricity. Example: hydrogen, oxygen, iodine, carbon, anything. Any non-metal thing. And what is metalloids? Metalloids is having
metal and non-metals.
Yes. Example: boron, silicon, and germanium. And about the elements and compounds I have told you guys. And now next part, let us go this homo and hetero. Yes. The impure part is divided into two parts. Impure substance. Okay, let me write here. Impure is divided into two things, two subparts, the homo. Yes, the homo and the hetero. Yes. And what is homo? Homo means around same phase.
Same. Homo means same, and hetero means, you know, like different. Like if you put like
And what?
hetero is like sand and water, oil with water.
Yes.
But homo is like sugar with water, salt with water, that sort of stuff.
Good. So here, homo, we can call it as true solution, because if we are mixing salt and water, it will be just one phase, so we can call it as a true solution. And in hetero, we can call it as it's not a true solution. है ना? Yes, Advika and
Yes, ma'am.
Razi,
Yes, ma'am.
Yes, ma'am.
getting it?
Yes, ma'am. I'm getting it.
Okay. Homo is a what? Homo is a true solution, and
True
here,
solution.
and hetero is also divided into subparts. Here, very much you guys will get the subparts, and hetero is also divided into two subparts. One is colloidal solution, and another one is suspension.
Ma'am, suspension.
Yes. And here in the true solution, the particle, see, here in the homogeneous, the particles are very small. Particles are small, means 10 to the power minus 9 or less than 1 nanometer. Less than 1 nanometer. Okay, and here in the colloidal, okay, let me, and in the colloidal solution, particles are very small. With the range of 10 to the power 9 m to 10 to the power minus 9 to 10 to the power minus 7 m. And in the suspension, the particles are large, means more than, here it's less than 1 nm, 1 nm. Here it's more than 100 nm, means 10 to the power minus 7 m. And here it's ranging from 1 to 100 m. Okay, and the next point is this solution, a true solution part is transparent, and this is translucent, and this one is opaque. This one is opaque. Now here, this is the homo, है ना? Salt plus water is homo. This is okay. First, let me. This is a colloidal. This is a heterogeneous. See, this is a colloidal. Means here this is somewhat translucent because somewhat visible. This part, this is colloidal solution, and this is a suspension. Suspension means opaque. Means it's not visible. Opaque example we can say chalk plus water. This is a opaque. Let me write it first, then you guys will relate easily. This is a transparent. This is a
Carbon is also opaque.
carbon. What?
Carbon.
Yes, carbon. Now this is transparent, translucent, and opaque. And the last point, which is particles cannot be separated by filtration. Here, particles cannot be separated. By filtration. Any example, anybody? Advika, any example? Particles cannot be separated by filtration?
Yes, ma'am. Salt and water.
Yes, very good. Salt plus water. And in this part, particles cannot, here also particles cannot be particles cannot be separated by filtration. Any
Sugar and water also. Sugar and water.
Sugar and water also. And here also the same, particles cannot be separated. Particles cannot be separated by filtration. Any example here? Any example? Milk. And in the suspension part, particles can be separated by filtration. Example, what are particles can be separated by filtration. Are there any example?
Maybe like oil and water. I don't know. Maybe.
No.
Sand and water.
Yes, sand and water. Because sand is heavier than water, so it will be separated, right? If we will filter sand, then sand will be there in our this filter part. Now here, see, this is what here my particles are very small. Particles are very small. 10 to the power minus 9 m means these particles are very, very, very small. And here in this opaque, This one is opaque. And here in this opaque, the particles are small, not very small as true solution. Here minus 10 to the power minus 9 m to 10 to the power minus 7 means somewhat this much. It's not very small. And here in this, this is the suspension part. Here the particles are very large, this much. Okay, now let me go through this. Here the colloidal solution is milk. We can say this example as milk. See here what's happening. This is somewhat translucent and particles cannot be separated by filtration. The milk cannot be separated by filtration. And one more point. Yes, the very important point. Here does not scatter the beam of light. I'll show you guys. Does not scatter the beam of light. And here scatters a beam of light. Scatters a beam of light. And here also scatters. So this one, this colloidal is a we can say the example is here milk. And what is opaque? The chalk plus water. Here the scatters. If we will pass a light, then what will happen? Light, the scattering of light will happen. Okay, I'll show you one video. So this much you guys got it now. Key impure is divided into two parts. One is homo. This my salt plus water is a homo, and this my chalk plus water. This is my chalk powder, which is dissolved in water. This is what? This is heterogeneous because the chalk is having some different phase and the water is having some different phase. And hetero is also divided into two parts. One is colloidal, another one is suspension. True solution, we can call it as homo, and in homo the particles are very small, just like this. The particles are very small. In the colloidal solution, the particles are not as very small as the true solution, means it will be little large. And in this opaque, in the suspension, the particles are very large. And this is my true solution is transparent. This is translucent. This is opaque. And here the particles cannot be separated by filtration. Example, salt plus water. If we will dissolve a salt and water, it won't be separated by a filtration process. And here the particles cannot be, here also particles cannot be separated. Example, milk. And in this opaque part and the suspension, the particles can be separated by the filtration. Example, sand plus water. Okay. Now see this part. Okay, first let me give you a small this introduction about. Anybody know about Tyndall effect? What is Tyndall effect?
Ma'am, what effect?
Tyndall effect. Tyndall. No, Advika? Any idea about this effect?
Ma'am, I think scattering of light.
Scattering of light. Yes. And Advika? Advika, are you there? Okay, so what is Tyndall effect? Scatters a beam of light is somewhat called a Tyndall effect.
Ma'am, I searched it on Google. It's like when like something like a beam goes through like water and it gets scattered.
See what happens? Like dust particles which is present in the room, which I am sitting in, room where Aram is sitting or where everybody is sitting, there is a dust. So in a room, if there is a hole, if there is a small hole, and from that hole, the beam of light will come just like this. For example, this is a room, and if in a room there's a small hole, the somewhat beam of light will come, and through from that beam of light will see the dust particles. If there is a room and in room there is a dust particle, and if a small hole is present in the room and the beam of light is coming, then what we will see, the small dust particles we will see. That's why this effect is called as a Tyndall effect. If a light is passed through a medium and its path can be seen, because for example,
if you put like laser beam through a specific type of substance, you can see the beam.
Yes.
Like if you put it through smooth, you can see it.
See here what happens if a light is passed through a medium. This is my medium. From here, this is my medium. from here light is passing, है ना? So if a light is passed through a medium, then what happens? Then its path can be seen, and we can also see the dust particles which is there, like we can see from this part of beam. If a light is passed through a medium and its path can be seen, so this effect is known as a Tyndall effect. Let me show you some things. For example, this is my flashlight, Arham, that laser, Arham. Here, this is what? This is a true solution, and here is a colloidal. This is a true solution, and this is a colloidal solution. Here, what I have told, ki true solution, light does not scatter. See, here does not scatter the beam of light, but in the colloidal solution, this is the colloidal solution, scatters a beam of light. This is my true solution. Here, my light is not scattering. Here, light is not scattering. But in this colloidal solution, what happens? The scatters of light is happening.
So now you can like see the light beam.
Like this.
Oh,
okay.
Like this.
Yes. Okay, just a minute. Let me show you. Okay, wait.
Check out this call experiment.
Voice is audible or not? No?
This class
I can hear it, but it's very low.
Okay, very low. Just a minute. Wait. Now? Okay. Only see this video. See what's happening if this is the beam.
Go ahead.
Any sound? If you will see, this guy is adding a milk in this colloidal solution. This is my colloidal solution. This part. Okay. If guy is adding a colloidal solution and see what happens, the scattering of light takes place in this colloidal solution.
Okay, oh my God, right.
Okay, but in the true solution, scattering of light is not happening. Okay. This phenomena is known as the scattering of light, and scattering of light phenomena is known as the Tyndall effect. Okay, got it?
Yes, ma'am.
Yes, ma'am.
Okay, so let me pause this. So here what's happening? This guy is adding a milk in this colloidal solution, because colloidal solution, the example of colloidal solution is what? Milk, है ना? So this guy is adding a milk in this glass. So, and if from here the laser light or some light is
I've seen one image of it.
Okay, good. Then this is the true solution. This is the colloidal solution. In this true solution, scattering of light does not take place, and this in a colloidal solution, scattering of light takes place. And this phenomena is known as the scattering of light. Okay, and this scattering of light thing is known as the Tyndall effect. Okay, everybody got it?
Yes, ma'am.
Yes. Okay, Razi. Now see here also, this is the same as this. This is the image that was the video. This is the true solution. Here light is not scattering. This is the colloidal solution. Light is scattering if we will add some milk, because this is the colloidal solution. Now let me explain this thing. See here, if this is my if we will, okay, see this part. If we are adding a salt in a water, then what is this salt? Salt is a solute or solvent? Arham.
Okay.
Razi, salt is solute or solvent?
Ma'am, solute.
Yes, salt is a solute, and we are mixing salt in water. So this medium is known as the solvent, and this full thing is known as the solution. Yes?
Yes, ma'am.
Solute plus solvent is known as the solution. And this is what? This is about the true solution. And if we will talk,
I wanted to actually one time I was in a car and it was very foggy, and when the headlights turned on, I saw the Tyndall effect.
Yeah, really?
I did.
Okay, good. And so this was for the pure solution, and let's talk about the colloidal solution. Here, if we are taking some, let's say some beaker or some funnel like this. So this is what, this is a addition, like here it's addition of what? Solute plus solvent, and here it's the addition of dispersed phase. And if we will mix something like milk is a dispersed phase, and we are mixing a milk in a water, so that water is a dispersion medium, dispersing medium. This is for a colloidal solution. And what is suspension? Anybody? Razi, what is suspension?
What, ma'am?
Suspension. Here I've told, no, this is the suspension. The particles can be separated by the filtration. Example, salt plus sand plus water. And here the particles are very large. Scattering of light also takes place, same as the colloidal solution. Okay. So in the suspension part, in the suspension solution, it will be there, like here in the okay, first let me draw. In the suspension, what the particles are very large, so it will be the addition of the particles medium plus suspension. The particles medium means the particles, and this is the particles medium, where in the suspension. Okay, because here the particles medium are very large. So okay, wait. This is the pure. This we covered this mixture. And here, what is the mixture? Mixture is a subpart of which topic, Aram?
What?
Mixture is the subpart of which topic?
Mixture is the subpart of it.
Pure substance, no?
What, ma'am?
Pure substance. Pure. See here. The pure substance is classified into two parts: the mixture and the compounds. Mixture is what? The elements or the compounds just mix together to form a mixture. And what is compound? The chemically combining the two elements is known as the compound. Okay.
Oh, got it.
Got it? And this is the mixture. In mixture, we have two parts: the homo and the hetero part. And what is the mixture? Mixture are constituted by more than one kind of pure form known as the substance. Example, the water, minerals, soils. Arham got it now, because it's a mixture of both the elements or compounds. If we mix together, then it will form a mixture. And mixture is divided into two parts: homo and hetero, that we have already discussed. The homo part and the hetero part. The homo is a true solution, and the hetero is again subdivided into two parts: the colloidal part and the suspension solution. Now, this is what? This is the, okay, it's already 48. Now, first, okay, wait. This, from the next class, we will discuss about the solution, but let me go through once again from this. Arham, matter is subdivided into two parts.
Two parts.
One is pure and another one is impure. है ना, Razi?
Yes, ma'am.
Yes. Matter is divided into pure and impure. What is pure? It consists of only one type of particles, like the oxygen. And what is impure? Which is two or more types of particles, means the tea. Because in tea, we have the mixture of the water, the milk, the sugar, है ना? Or the coffee. And the coffee is also impure. Now, the pure is divided into two parts: the mixture and the compound parts. Arham? Pure substance is divided into two parts: elements or compounds, or we can say mixture or compounds. Okay. In compounds are what? Combination of two or more different chemical elements, like water. H2 plus O is known as will give what? H2O is water. And what is element? Simplest form of matter which cannot be further divided, like oxygen. It's an element. Now, this matter, pure, impure, again pure, element and compounds. Now, the elements are divided into three subparts. One is metal, non-metal, and metalloids. Metal is ductile, malleable, sonorous. Non-metal is neither ductile nor malleable. And what is metalloids? It's a mixture of both the metals and the non-metals. Yes, Arham? Razi, getting it?
Yes, ma'am.
Yes. Now, this done, matter, pure, impure. I want to summarize you guys, like matter, pure, impure, pure, elements and compounds, elements, three parts, metals, non-metals, metalloids. And this impure part is also known as the mixture. And the mixture is a combination of mixture can be furtherly divided into two parts, the homo and the hetero. Here my salt water is homo solution and my chocolate milk is, chocolate milk is what? Homo or hetero?
Ma'am, hetero.
Chocolate milk is a heterogeneous because it's a mixture of two parts and it will settle down. Chocolate will settle down now. So then chocolate will have some different phase and then milk will have some different phase. That's why it's a heterogeneous. Homo and hetero, homo salt, hetero sand. And what next? Here the pure, the mixture and the compounds. And here the same thing. The elements is divided into three subparts: metals, non-metals, metalloids. Metals are malleable, metals are sonorous, metals are ductile. Here not nor malleable nor ductile. Metalloids is a combination of two parts. It's a combination of two metals and non-metals. And here in the mixture we have discussed one is homo, another one is hetero, and hetero is again divided into two parts: colloidal solution and the suspension solution. Colloidal solution is translucent. This one is opaque, and my true solution is transparent. Okay. And this homo is what? Particles cannot be separated by filtration, like salt plus water. Very easy. Colloidal milk also cannot be separated by filtration, and here sand plus water can be easily separated by the filtration. And what next? And we have talked about the Tyndall effect. What is Tyndall effect? The scattering of a light. If a light is passed through a medium, this is my medium, this is a beam of light, so this is known as the scattering of light. Like here, if this is my flashlight and this is my true solution and here is my colloidal solution. So in true solution, we have already discussed the light do not scatter here. And
light does not scatter, but in the semi-light solution, it will scatter, so you will see the beam.
Yes. So this was the video. Okay, now can I ask?
Tyndall effect happens when motorcycle when motorcycles smoke, right?
What?
Ma'am, like when the motorcycle releases smoke, the Tyndall effect also happens there, right?
Somewhat we can say, because it's also a beam of, and also we can see the dust particles. So the scattering of light is known as the Tyndall effect. Simple.
Okay, ma'am, got it.
Okay, and Arham. Chalo, question. A pure substance is divided into how many parts?
Two parts.
Come on, fast.
Impure and pure.
Again, the pure is divided into how many parts?
Two parts.
Yes, Razi will answer. You wait. Razi?
Yes, ma'am.
Yeah, pure substance is divided into how many parts?
Two parts, elements and compounds.
Yes, very good. And elements is divided into how many parts? Anybody? Razi or Arham?
Ma'am, three parts. Metal, non-metal and metalloid.
Very good. And the impure is also known as?
Ma'am, mixture.
Yes, very good. Mixture. And Arham, mixture is divided into how many parts?
Ma'am, mixture was divided into
how many parts? Yes, Razi.
Ma'am, two parts, homogeneous and heterogeneous.
Yes, Arham, mixture is divided into two parts, na? See here also mixture, types of mixture. One is another one is hetero. Okay, and hetero is divided into how many parts?
Hetero, two parts.
What are they?
Superstition and
superstition. Suspension.
Suspension. I can't pronounce
and another
one. I don't know how to pronounce it.
Razi?
Colloidal.
Yeah, colloidal, solution and suspension. Aram, see it's here also. Heterogeneous colloidal solution and the suspension. And solution, scattering of light takes place or not?
Yes, ma'am, it takes place in the colloidal effect.
Scattering of light takes place. Yes, scattering of light takes place. And in the true solution, scattering of light,
it does not.
Because here, true solution, scattering of light is not taking place, but here it takes. No? Okay. Now again, and here, okay. Transparent is true solution. My colloidal or suspension? Transparent.
Not true solution.
Yes, very good. And the translucent and the opaque?
Non suspension.
And the translucent?
Colloidal.
Yes, colloidal. Okay. And here we have the very small particles in the true solution. in this the colloidal we have the not that much small as true, but we have small, and in this we have the larger particles. Okay, and this oil and water is a heterogeneous because the oil will have some different phase, the water will have some different phase. Okay, got it?
Yes, ma'am.
Everything, each point, no doubt. Any doubt?
No, ma'am.
Okay, ठीक है. Thank you. Bye.